So, yeah. So differentiation. So if you something like y is equal to x squared, and I asked you for dy dx, right? Okay. Remember this, you bring the power down in front and reduce the power by 1. So you bring that 2 down in front, you're left with an x, and you reduce that x to the power of 1. But x to the power of 1 is just 1. Remember this? No. Right, if we had y is equal to x to the power of 3, dy dx, bring the power down in front, reduce the power by 1. So what will I get? 3x squared. So bring the 3 down in front and reduce that by 1. Okay? Right, if I said y was equal to 2x to the power of 4, dy dx differentiated, and as I say, I'll remind you why in a minute. I'm just reminding you how at the moment. So you bring the 4 down in front, but there's a 2 already there. So what will I do? Multiply. So 4 by 2 is 8x to the power of what? 3. Okay. If you had a whole line of 2x cubed plus 4x squared plus 3x minus 1. Now, I haven't done these ones yet, but I'm going to do them now in a minute. So if I asked you to differentiate this whole expression, you do each term individually. So what will I do here? 6x squared. Bring down the 3. There's a 2 already there. 3 2s are 6. Reduce the power by 1. Yeah? Okay. Here, bring the power down in front, multiply it, reduce the power by 1. What will I get? 8x. 8x to the power of 1, which is just 8x. Now, when you differentiate an x term, girls, you just get the number in front of it. So when you differentiate an x term, you just get a 3. And when you differentiate a number on its own, a minus 1, right, you just get 0. Right, okay? So anytime you differentiate a number by itself, you just get 0. Is that alright? Sometimes, instead of y equals, they might say f of x is equal to. There's just another way of asking you the exact same question. So if I go 4x squared, no, I'll go cubed, minus 6x squared plus 2x, sorry, I'll go minus 2x, and I'll go plus 7 at the end. Okay? If they call it f of x, girls, to differentiate, they call it f dash of x. Is that okay? So it's instead of y and dy dx, we've f of x and f dash of x. It's the exact same thing, it's just a different way of writing it. Is that okay? So, differentiate there for me. 12x squared. What's next? Minus 12x, isn't it? Keep going. Minus 2. And then plus 7 is 0. So the x term, you just get the number in front of it. Watch the sign, keep the sign. Differentiate a number, you get 0. Are we okay with that? Is everyone alright with that? Right. Sorry? Yeah, that is the answer. So sometimes they'll say y is equal to 3x squared minus x plus 3. And then it'll say find dy dx when x equals 1. Okay, so an extra step, find dy dx when x equals 1. Find dy dx first. So dy dx is just differentiate. So find dy dx. So what is dy dx? 6x minus 1. Remember, there's a 1 in front there. People get caught on that a lot. Okay, they put 0. But there's a 1 in front there, so it's minus 1. 6x minus 1. Right, this is the extra step. Right? When x equals 1, that means everywhere you see an x, put in a 1. Right? So 6 times 1 minus 1 into the calculator, that, and you get 5. So your final answer is actually 5. Okay? So when this extra bit is here, You get dy dx, and then instead of x, you put in the 1. Is that alright? Okay, sometimes they might go find dy dx at the point 1, 3. Okay? Is that alright? So you don't, remember a point is x and y. The y is irrelevant, you don't need it at all. They've given you extra information. All you need to take out of that is that x is 1. Is that right? So you fill in 1 for x. Okay? So if I said at the point 2 minus 3, what would I fill in for x? 2, right? Okay, this is x, isn't it? So I'd get dy dx, and then I'd fill in 2 for x. Is that alright? Okay, so if I said find it at the point minus 1 minus 2, what I fill in for x? Get dy dx, what I fill in for x? Minus 1. Okay, this extra bit of the point is irrelevant, you don't need it. Is that alright? Are we good?
Can you look just for a second?
Yeah. Sorry. Right, okay. So when you're differentiating, you're actually finding the slope of the tangent. So find, actually I might make a list, right? Okay, when to differentiate. Sorry, yeah. When to differentiate, right? And when we did differentiation, I gave you this list. Okay, so how do you know when are you supposed to do this? Okay, so there's lots of different ways. The first one, the simplest one, is find dy dx. Right, a second way they might ask you, and I showed you this way in a minute, or a minute ago, is find f dash of x. This is how you know to differentiate. Okay, and you have this list in your notes. It's in your notes, right? What are we actually doing? We're finding the slope of the tangent to the curve. Find the slope of the tangent to the curve. Find the slope of the tangent to the curve, right? If they ask you to find the turning points, if they ask you to find the maximum of or the minimum, or if they ask you to find the rate of change, who cares what, right? Okay. Okay, are we good? right? That's when you know to differentiate. So this is how they ask you to differentiate without actually using the words differentiate. Obviously, they could also say differentiate. Okay, is that right? Okay, we'll do an example of each one, right? So I've just done the straightforward dy dx f dash of x. Find the slope of the tangent to the curve, okay? So if you had a question like, oh, I go for time. Okay. Right, so find the slope, the tangent what that says curve. I don't know what way I've written it. Right, I'm just going to do a quick sketch to show you what I'm doing, okay? But if you don't need the sketch in the exam, you just go ahead and do it. But this is just to give you an idea of what you're doing, right? This is a curve, this is a happy face, okay? At one point on the curve, we'll say -2, 3. You can draw a tangent. So a tangent, remember a tangent is a line that hits the curve at one point only. Would you agree? That's a tangent. We've had that that's come up lots of times. So a tangent is a line that hits the curve at one point only, and they've told us where it hits the curve, right? And the question is, first off, to find the slope of this line, and then to find the equation of this line. Okay? So find the slope of the line is one of the things on the list. So what am I going to do? What will I do to find the slope of the line? I'm going to, so y is equal to 3x squared plus x minus 7. So if I'm looking to find the slope of the line, what am I going to do? Differentiate. So I get dy dx. Differentiate this, please. 6x plus 1. Right? Okay. Is that alright? Now it's at the point -2, 3. So what I do? Sub in what for x? -2. Does that 3 matter? No. No. Who cares about what the y is? This is the important thing. X is -2. So everywhere I see an x, I put in a -2. So it's -2 plus 1, which is -11. So the slope of this line here is -11. Is that okay? Right, then you need to go to a coordinate geometry of the line. We need to find the equation of that. So off you go to your log tables, and to find the equation of a line, this is what you need to fill in. So everywhere I see an x1, I'm putting in a -2. Everywhere I see a y1, I'm putting in a 3, and my slope is -11. Are you with me? So it's y minus 3 equals -11 into x minus -2. That becomes a +2. Multiply out and tidy it up if they want you to, but if they don't say tidy it up, that's full marks. Is that right? Okay, are we good with that? So my point here was, if they use the words find the slope of the tangent to the curve, what do? Differentiate, right? So they mightn't say differentiate. They're not going to say differentiate. They're going to say find the slope of the tangent to the curve, and you need to know that you need to differentiate. Is that okay? Right. Okay. Another way they'll ask you to differentiate is they'll ask you to find the turning points. Find the turning point of let's see, y equals x squared minus 2x plus minus 5. Okay, right? So this is the rule, this is the bit you need to remember. At the turning points, I'm just writing TP, dy dx equals 0. If you write that down, they will give you max, okay, because that's what it's all based on, right? And you need to remember that. At the turning points, dy dx equals 0. So what do I get? What do I get first before I start? Dy dx. So what is dy dx? I wouldn't mind if someone else talked. Sorry. Well, at least you're talking. Right, apologies. Right, find dy dx. So what is dy dx? 2x minus 2. What I do now? Let it equal to 0. So you get 2x minus 2 equals 0. X is on one side, numbers on the other. So leave the 2x, bring the minus 2 over the wall, it becomes a plus 2, yeah? Divide each side by 2, and you get x is 1. Now they ask me for the turning point. So in order to get a point, I have x. What do I need to get? I need to get a y, don't I? So I sub it into the very top. So y equals x squared minus 2x minus 5. So everywhere I see an x, I'm going to put in a 1. So y is equal to 1 squared minus 2 times 1 minus 5 into the calculator with that, and that will give you minus 6. Okay, so your point is 1 minus 6. X is 1, y is minus 6. Are you good? Right. Okay, now sometimes they ask you, is it a maximum or a minimum turning point? Right? You know the shape of this. If I was to draw this, what shape would it be? It'd be a smiley face, wouldn't it be a happy face, wouldn't it? Because the x squared term is positive, so it'd be a smiley face. So this is the turning point, right? Is that a max or a min? Is it up high or down low? It's a min, isn't it? So it's a minimum turning point.
So can you ask that like before you even do the differentiation?
Yeah, before you even did the differentiation and let it equal to naught, you know the shape of that graph is going to be a minimum.
So there's only matter like what the signs are between the...
Yeah, so they asked me to find the turning point. Okay, so I still have to find the point. Right, is that okay? Right, I had one of those. Right, sorry now. If I have y equals 2x cubed minus 3x squared minus 12x plus 7, and it says find the turning points and state whether they're a max or a min, and say whether it's a max or a min. This is a cubic equation. Cubic equation, girls, has a look like that. Okay? This is a turning point, and this is a turning point. So there's going to be two answers here. Right? There's going to be two answers. So you actually get a max and a min if it's a cubic equation. If it's a quadratic, you either get a max or a min, right? But now you get a max and a min. Is that okay? Right. Same step though. We know dy dx is equal to 0 at the turning point. Agreed? How do you know that? Because you've learnt it, right? And it will come out when you see the words turning point. Differentiate 6x squared minus 6x minus 12 equals 0. Minus b formula, that's how you solve here when you have an x squared term, minus b formula, or the factorising. Okay, I'm going to divide everything by 6 because it'll make it handy. That would be x squared minus x minus 2 equals 0. As I say, minus b formula, where you go if you prefer. Factorise 2 sets of brackets, x and x. Factors of 2 are 2 and 1, and I want to end up with a different sign. I want to end up with a minus 1, so that's minus 2x plus 1x. Is that alright? Then you let each bracket equal 0, so you get x minus 2 equals 0, so that would give me x equals 2, and then I get x plus 1 equals 0, and that will give me x is equal to minus 1. Agreed? So for each x, what do I need to get? I need to get a matching y. So I go right back up to the very top. So y is equal to 2x cubed minus 3x squared minus 12x plus 7. So I have to fill in x is 2. So y is equal to 2 times 2 to be cubed minus 3 times 2 to be squared minus 12 times 2 plus 7, that's 16, take away 12 is 4, minus 24 is minus 20, minus 13 I think. Okay, so that's your point, 2 minus 13. Is that okay? Then you have to get a matching y for when x is minus 1. So you get y is equal to 2 times minus 1 to be cubed minus 3 times minus 1 to be squared minus 12 times minus 1 plus 7. Type it into the calculator as you see it, and that would be minus 2 minus 3 is minus 5, minus 5 plus 12 is 7, and 7 plus 7 is 14. Okay, so that's the point, minus 1, 14. You with me? Now to figure out which is a max and which is a min. The max is up high and the min is down low, right? So out of those 2 points, imagine in your head you're drawing them, right? And if imagining isn't good enough, have a quick sketch, right? Minus 1 to 14 goes across to minus 1 up to 14, wouldn't that be right? Whereas 2 minus 13 would go across 2 down to minus 13. So which one's up high, which one's down low? Which is the max? Minus 1, 14. That's the max. That's the min. Are we good with that? Max and min. Turning points. Right, okay. How am I going for time? I don't know, because stupid number. 2 minutes past. Right, okay. So the next thing is, girls, distance, speed and time. Right, okay, distance, speed and acceleration, sorry. Right, and this is something you have to learn. Right, and as I say, this is all in your notes. Okay, distance, speed, acceleration. So to go from distance to speed, guess what you do? What chapter are we in? You differentiate. And if you want to go from speed to acceleration, what I do? Differentiate. Okay, and if I want to go from distance to acceleration, I have to differentiate twice, don't I? Differentiate and differentiate again. Agreed? Okay, for example, and they'll give me a body moves along a straight line and its distance s, so they're telling me s is the distance, right, equals 3t cubed minus 4t plus 6, right? Okay, so that's distance. Now it's very annoying that they use s for distance, but that's what they do. So it's not speed, s is distance, is that alright? And t is time, right? Okay, and they said find speed, so the first question is find speed after t seconds. Okay, so how do we find speed after t seconds? What do we know? We know if you have distance, how do you get speed? Differentiate, so differentiate that. So differentiate that and you'll get 9t squared minus 4. That's it? Is that right? That's find speed after t seconds. And then it says find speed after 2 seconds. So we have an expression for speed. This is speed, isn't it? So how do we find that after 2 seconds? What do I do? Everywhere I see a t, put in a 2. Right? So it's 9 times 2t squared minus 4, which turns out to be 32. Is that right? Okay. Then find its acceleration after 3 seconds. Right? Okay, so acceleration, right, you differentiate to get speed, and then you differentiate again. So differentiate this again. What I get? 18 t. That's it, isn't it? And after 3 seconds, what will I do? Put in 3 for t, so that's 18 times 3, and 3 18s are 54. Is that okay? The end. Right, that's differentiation in a class. Considering it took me 3 weeks to teach it, I don't know what I was doing. The bell's going to go in about 1 tick. So, have you a suggestion for a topic tomorrow? I was trying to pick topics that we haven't done since last year. Functions? Yeah, I'll have a look over functions so tomorrow. Right? Say that again? I didn't. Will I do that tomorrow? Will I give back the geometry sheets and the trigonometry sheets? Or will I revise functions? I go give them back and don't go through them. Right, okay, I'll do that tomorrow. I have the geometry one corrected as well. I forgot that was my plan for this week, but I think what I did there was better.